Let's see. I'm trying to understand. Okay, so if somebody, let me lower the volume. So if somebody's with me in VC, yeah, they can't see my screen, but I want anyone who joins. I'm so confused. So StreamYard is sharing. Let me kill this for now. So StreamYard, I'm sharing my screen, but I also want. This is StreamYard, but I also want. I can't click this. To share my entire screen. I don't know if this is on or off. It's impossible to know. That was weird. Okay, anyone who joins can see me. So it's being streamed both. So StreamYard is capturing the screen, and so is. Okay, let's copy paste this. And let's copy paste this. The question is, can you hear me? The question is, can you hear me? Yeah, you can me you can hear. The question is, can you hear my YouTube? The question is, can you hear? Okay, I can see that you cannot hear. You cannot hear the YouTube. So can I modify the share? I don't remember what I clicked with. You know what the problem? The problem is that this is in dark mode. Can I turn dark mode off and stop sharing and start sharing again? Maybe this is on. I don't know. It's impossible to know. Is this on or off? Or is this on? Is this on or is this? I don't know. I don't know. I don't know which is on, which is off. Let's try it again.
But Bob can exactly recreate it on his end. It does not break the speed of light limit because Alice has to send information about her measurement outcome, but it's an entirely new method of information transfer. Quantum teleportation was successfully done first in 1997 by the groups of Stanley Popescu and Anton Selinger. By now, they do it in space.
Okay, let's see.
Look at the citations to the EPR paper again. They're higher now than ever before. Quantum technologies have a lot of potential that we're only now beginning to explore. And this isn't the only reason this research matters. It also matters because it's pushing the boundaries of our knowledge. It's an avenue to discovering fundamentally new properties of nature.
You see, 3 years ago, she was talking about this nonsense like a believer. Okay, so we need I want to also share my entire screen. But I wish it would just say on or off. Is this on or is this on? I don't know. This is the most bizarre thing in the universe. How can you tell which is on, which is off? And there's no way to modify it after you select. Also share system audio. Which is on? Is this on? Let's look it up. Also share uh also share system on Discord. Image. Where's the also share window? What is it? Choose what to share. Also share system audio. Also share system audio. Let's remove the Discord. Also share system audio. Um, no one ever discusses this button. No one cares. No one is confused by this. I'm the only person in the world who cannot tell which is on, which is off. It's a it's a checkbox on off. Mm. No one ever captured this button. I don't have the snipping tool. What is this? Important account notifications. Where's the snipping tool? Pin. So I'm just looking for this. Can we search? Does Brave allow us to search? Is there an image search? Is there a Brave image search? Brave image search. Um, Private search engine. Answer with AI. I don't have another option. I need to. Okay, let's assume that this is on. Let's share it. The question is, can people on I can't check because I'm not on I can't go to Discord now as I'm on Discord on the laptop, so I can't know. Yeah, this is terrible. Okay, let's forget about it. Let's just continue. So this is Sabine
Because maybe Einstein was
3 years ago.
right after all, and quantum mechanics isn't the last word. Today, research on quantum mechanics is developing so rapidly it's impossible to keep up. There's quantum information, quantum optics, quantum computation, quantum cryptography, quantum simulations, quantum metrology, quantum everything. It's even brought the big philosophical questions about the quantum foundations back on the table. I think a Nobel Prize for the second quantum revolution is overdue. The people whose names are most associated with it are Anton Zeilinger, John Clauser, and Ernest Baer. They've been on the list for a Nobel Prize for quite some while, and I hope that this year they'll get lucky. This video was sponsored by Brilliant, which is a website and app that offers interactive courses on quantum mechanics is more than 100 years old. That sounds like it's the stuff of dusty textbooks, but research on quantum mechanics is more active now than a century ago. That's because many rather elementary facts about quantum mechanics couldn't be experimentally settled until the 1980s. But then, by the year 2000 or so, experimental progress had totally transformed the field. Today, it's developing faster than ever. How did this happen? Why does it matter? And what's quantum teleportation? That's what we'll talk about today. Before we talk about the second quantum revolution, big thanks to our tier 4 supporters on Patreon. We're clicking on the join button just below. He thought quantum mechanics couldn't possibly be tough. Albert Einstein was famously skeptical of quantum mechanics. Hi, Albert. He thought quantum mechanics couldn't possibly be a complete description of nature, and he argued that something was missing from it. You see, in quantum mechanics, we can't predict the outcome of a measurement. We can only predict the probability for getting a particular outcome. Without quantum mechanics, I could say, if I shoot my particle cannon, then the particles will land right there. With quantum mechanics, I can only say they'll land right there 50% of the time, but have a small chance to be everywhere, really. Einstein didn't like this at all. He thought that actually the outcome of a measurement is determined. It's just that it's determined by hidden variables, which we don't have in quantum mechanics. If that was so, the outcome would look random just because we didn't have enough information to predict it. To make this point, in 1935, Einstein wrote a famous paper with Boris Podolsky and Nathan Rosen, now called the EPR paper. In this paper, they argue.
I still don't understand what Einstein meant by incomplete. I don't know. What's the I don't understand this thing. He couldn't live with randomness. I don't know what that means. Like, what's the experiment you're having a hard time with? I don't understand.
That quantum mechanics is incomplete. It can't be how nature works. They were the first to realize how essential entangled particles are to understand quantum mechanics. This would become super important and lead to art technologies such as
What?
EPR paper. In this paper, they argued that quantum mechanics is incomplete. It can't be how nature works. They were the first to realize how essential entangled particles are to understand quantum mechanics. This would become super important and lead to art technologies such as quantum teleportation.
I never know with her or with many physicists when they explain a topic, I never understand what the issue is. What is the question? What I mean by that is, show me the experiment you're having a hard time explaining. Let's start from that. Let's synchronize. You've seen an experiment. Show me the experiment that you're having a hard time explaining. Let me try to have a go at it. And if I fail, then we can have a discussion. But what is the experiment you're talking about? I don't understand.
Which I'll tell you about in a moment. Entangled particles share some property, but you only know that property for both particles together. It's not determined for the individual particles. You may know, for example, that the spin of two particles must add up to 0, even though you don't know which particle has which spin. But if you measure one of the particles, quantum mechanics says that the spin of the other particle is suddenly determined, regardless of how far away it is. This is what Einstein called spooky action at a distance.
Why is that surprising? This I cannot understand. Why is that surprising? Why is that spooky action? I don't understand the issue. I don't understand the issue. So you measured one. And you want to recreate a measurement of the other that will be entangled, that will be correlated. Okay. Then let me show you. Oh, I turned it off. Let me make sure that I'm. Oh, wait. Oh, okay, I'm okay. Okay. So here. So this is plus 170. But if we do plus 180, so we're measuring them in opposite directions. I'm waiting for this to complete. Now it's running. 100% of the time, it's either up, up, or down, down. That's because we set them up to be exactly 180 degrees from each other. So when I tell particle 2, right, I tell particle 2 to measure itself. I give it a measurement angle, and it only also have its spin. And it decides to be up or down, that is 100% correlated with particle 1, even though particle 2 doesn't know the measurement outcome of particle 1. And in order to accomplish this, I used where is this? Self-randomness. So when the particle was created, I gave it a spin angle and a randomness variable. And this randomness variable is shared between the two particles. So the spin angle, but we can also, we don't actually need this randomness. We can create a random variable from a pseudo-random from the spin angle. We could also do that if you want. Instead of the randomness, we don't have to use randomness, but it doesn't matter. This is literally the random variable. I don't even need the random variable. I could have created it from the spin, but you can see this is 100% correlated. If I change them by 1 degree and I run it, it should run fast. How many times is it running? What's the size of the data? It's very big. Let's make it just 10,000 so it doesn't take too long. So you already see that sometimes we get non-correlated. It's becoming uncorrelated. I mean, it's still correlated, but it's not exactly 100%. Right, at 180 degrees, right? This fits the point is this fits the data. This is exactly the data. It's on. Why is it so white? And this shows, right? This anyway, so I don't know what's strange. I don't understand this reaction. I don't understand it. I don't know what is being I don't understand what is being argued. If somebody could please tell me what is being argued. I don't get it.
And it's what he, together with Podolsky and Rosen, tried to argue can't possibly be real. But Einstein or not, physicists didn't pay much attention to the EPR paper. Have a look at this graph, which shows the number of citations that the paper got over the years. There's basically nothing until the mid-1960s. What happened in the 1960s? That's when John Bell got on the case. Bell was a particle physicist who worked at CERN. The EPR paper had gotten to think about whether a theory with hidden variables can always give the same results as quantum mechanics. The answer he arrived at was no. Given certain assumptions, any hidden variable...
The answer he arrived was no. Given certain assumptions, any hidden variable theory will obey
theory will obey an inequality, now called Bell's inequality, that quantum mechanics does not have to fulfill. Great. But that was just maths. The question was now, can we make a measurement in which quantum mechanics will actually violate Bell's inequality and prove that hidden variables are wrong? Or will the measurements always remain compatible with the hidden variable explanation, thereby ruling out quantum mechanics? The first experiment to find out was done in 1972 by Stuart Friedman and John Clauser at the University of California at Berkeley. They found that Bell's inequality was indeed violated and the predictions of quantum theory were confirmed. For a while, this result remained somewhat controversial because it didn't have a huge statistical significance and it left a couple of loopholes by which you could make hidden variables compatible with observations. For example, if one detector had time to influence the other, then you wouldn't need any spooky action to explain correlations in the measurement outcomes. But
That's so funny. So, okay, whatever. I mean, what's the mechanics? How would they have shared information? Even that's, I would argue, that's already magical, but fine. As long as you're not violating the speed of light, that's a good start. You still have to explain the mechanics by which they're sharing information in real time.
in the late 1970s, physicists found out how to generate and detect single photons, the quanta of light. This made things much easier, and beginning in the 1980s, a number of experiments, notably those by Elias Baer and his group, closed the remaining loopholes and improved the statistical significance. For most physicists, that settled the case. Einstein was wrong. Hidden variables can't work. There is one loophole in Bell's theorem called the free will loophole that cannot be closed with this type of experiment. This is something I've been working on myself. I'll tell you more about this another time. Today, let me just tell you what came out of all this. These experiments did much more than just confirming quantum mechanics. By pushing the experimental limits, physicists understood how super useful entangled particles are. They're just something entirely different from anything they had dealt with
No, they're not.
before. And you cannot only entangle two particles, but actually arbitrarily many. And the more of them you entangle, the more pronounced the quantum effects become. This has given rise to all kinds of applications. For
I don't even know what she's talking about. Entangling more particles. I don't know what she's talking about.
example, quantum cryptography. This is a method to safely submit messages with quantum particles. The information is safe because quantum particles have this odd behavior that if you measure just what their properties are, that changes them. Because of this, if you use
see, she believes in this mystical, spooky action at a distance. She believes Einstein was wrong.
encrypt a message, you can tell if someone intercepts it. I made a video about this specifically earlier, so check this out for more. You can also use entangled particles to make more precise measurements, for example, to study materials or measure gravitational or magnetic fields. This is called quantum metrology. I have also a video about this specifically. But the maybe oddest thing to have come out of this is quantum teleportation. Quantum teleportation allows you to send quantum information with entangled states, even if you don't yourself know the quantum information. It roughly works like this. First, you generate an entangled state, and you give one half to the sender.
There you go.
Alice,
You see, a magic hat. So she doesn't know how this works.
To the receiver, Bob.
This is mysticism. This is magical thinking.
Whatever that is, it's just another quantum state. She mixes it together with her end of the entangled state. That entangles her information with the state that...
Okay, as long as no one is with me, so let me go to PNR. And let me create a room so we can talk to people about this. Join to create. Why is this join to create? Okay. Quantum entanglement is BS. Okay. And on P, I'm not high level enough. Join to create, but there's no... But there's no way for me to create. Okay. It doesn't matter.
that is entangled with Bob, and then she makes a measurement. The important thing is that this measurement only partly tells her what state the mixed system is in, so it's still partly a quantum thing after the measurement. But now remember, in quantum mechanics, making a measurement on one end of an entangled state will suddenly determine the state on the other end. This means Alice has pushed the quantum information from her state into her end of the entangled state, and then over to Bob. But how does Bob get this information back out? For this, he needs to know the outcome of Alice's measurement. If he doesn't have that, his end of the entangled state isn't useful. So Alice lets Bob know about her measurement outcome. This tells him what measurement he needs to do to recreate the quantum information that Alice wanted to send. So Alice put the information into her end of the entangled state, tied the two together, sent information about the tie to Bob, who can then untie it on his end. In that process, the information gets destroyed on Alice's end, but Bob can exactly recreate it on his end. It does not break the speed of light limit because Alice has to send information about her measurement outcome, but it's an entirely new method of information transfer. Quantum teleportation was successfully done first in 1997 by the groups of Sandro Popescu and Anton Zeilinger. By now, they do it in space. I'm not kidding. Look at the citations to the EPR paper again. They're higher now than ever before. Quantum technologies have a lot of potential that we're only now beginning to explore. And this isn't the only reason this research matters. It also matters because it's pushing the boundaries of our knowledge. It's an avenue to discovering fundamentally new properties of nature. Because maybe Einstein was right after all, and quantum mechanics isn't the last word. Today,
I don't get it. I mean, she's reversing. I mean, everything she's trying to say is that Einstein was wrong. And now she's saying Einstein was right after all. There is no spooky action at distance. There is the hidden variables. She's quoting the EPR. I'm so confused.
Wait,
Yes.
are you talking to yourself?
No, I'm streaming on YouTube. What's up?
Oh, I'm sorry, man. So, like, what's the context of this here? Like, what's going on?
The context is that I. Okay, that was fast.
research on quantum mechanics is developing so rapidly it's impossible to keep up. There's quantum information, quantum optics, quantum computation, quantum cryptography, quantum simulations, quantum metrology, quantum everything. It's even brought
I don't understand what she's saying. I'm so confused by her position.
the big philosophical questions about the quantum foundations back on the table. I think a Nobel Prize for the second quantum
At this
revolution
point, I'm basically an expert in the field, and I literally have no idea what she's talking about. I just don't understand what she's saying.
is overdue. The people whose names are most associated with it
It's
are
like everything she's saying is upside down, inside out, and again upside down, inside out. Like she's completely confusing the. I mean, mixing up the deck of cards, and I'm trying to follow where my card is, and I can't. I just don't know what she's talking about. This is completely useless. Okay, we'll come back to minute physics. Non-locality.
Locality means that to get from one point to another, you somehow have to make a connection in space between these points. You cannot suddenly disappear and reappear elsewhere. At least that was Einstein's idea. In quantum mechanics, it's more difficult. Just exactly how quantum mechanics is and is not local, that's what we will talk about today. To illustrate why it's complicated, let me remind you of an experiment that we already talked about in the previous video. Suppose you have a particle.
How can she just go live with her nipples protruding like this? I don't get it. Well, why is she wearing such a tight tank top? I mean, it's not like she's trying to sexualize. This is completely desexualizing her, but I just don't get it.
Particle with total spin 0. The spin is conserved and the particle decays into new particles. One goes left, one goes right. But you know that the two new particles cannot each have spin 0.
It's like too small for you. Just wear something. I just don't get it. Did anybody leave a comment about that? She probably deleted comments about her nipples. There it is, 31. Uh, this channel has everything. Watch out for those high beams. She blinded me with science. Some of my favorite things in the world. Never have I been this interested. Anyway, yeah, so everyone noticed it.
Each can only have a spin with an absolute
I once saw a picture of Melania high beams, and I never could find it again. Melania high beams, so beautiful, so perfect. She was wearing a white dress. Oh my god. Be best. Be best. That's the logo. Be best. I'm launching my new campaign. Be best. Be best. Um. mm, mm. They promised us that she left him. She does. They don't sleep together. They don't talk. That she hates him. So it was all just another lie. She never left him. and no one ever retracted this lie. So these people have no problem just making up lies.
value of 1. The easiest way to think of this spin is as a little arrow. Since the total spin is 0, these two spin arrows of the particles have to point in opposite directions. You do not know just which direction either of the arrows points, but you do know that they have to add to 0. Physicists then say that the two particles are entangled. The question is now what happens if you measure one of the particle spins.
So this says, let me tell you what the equation
To add to
says.
0. Physicists then say that the two particles are entangled. The question is now what happens.
Okay, so this is the Dirac, it's known as the Dirac notation. So the wave function, the state of the particle of the system, the state of the system is the square root of 1/2, because when you square psi, you get the probability. So it's going to be 1/2. So it's going to be 50-50. 50% up, 50% down. Whatever you measure, you're going to get 50-50. And then there is an option that one is up, the pink is up and the hazel is down, or the pink is down, the hazel is up. That's it. These are and this makes up, right? These are the two options of the system. Basically, this is what it says.
If you measure one of the particle spins. This experiment was originally proposed as a thought experiment by Einstein, Podolsky, and Rosen, and it is therefore also known as the EPR experiment. Well, actually, the original idea was somewhat more complicated, and this is a similar version that was later proposed by Bohr, but the distinction really doesn't matter for us. The EPR experiment has meanwhile actually been done many times, so we know what the outcome is. And the outcome is that if you measure the spin of the particle on one side, then the spin of the particle on the other side has the opposite direction. Okay, I see you are not surprised, because we knew this already, right? So what is the big deal? Indeed.
No, it is a big deal. I mean, how does it work? I mean, you need to explain how that works. No, you don't need to explain how that works? What do you mean we knew that? I'm so confused by her. I don't know. I don't know. I don't know what she's saying. I don't know. Who understands what she's saying? She's always cryptic. She's always talking as if everything is so obvious, and I never understand what she's saying.
Space between these points. You cannot suddenly disappear and reappear elsewhere. At least that was Einstein's idea. In quantum mechanics, it's more difficult. Just exactly how quantum mechanics is and is not local, that's what we will talk about today. To illustrate why it's complicated, let me remind you of an experiment that we already talked about in a previous video. Suppose you have a particle with total spin 0. The spin is conserved and the particle decays into new particles. One goes left, one goes right. But you know that the two new particles cannot each have spin 0. Each can only have a spin with an absolute value of 1. The easiest way...
Oh, they can both have spin 0. But there is a possibility that they both have non-zero spin. In that case, they have opposite spins, opposite but equal spins.
To think of this spin is as a little arrow. Since the total spin is 0, these two spin arrows of the particles have to point in opposite directions. You do not know just which direction either of the arrows points, but you do know that they have to add to 0. Physicists then say that the two particles are entangled. The question is now what happens if you measure one of the particle spins. This experiment was originally proposed as a thought experiment by Einstein, Podolsky, and Rosen, and it is therefore also known as the EPR experiment. Well, actually, the original idea was somewhat more complicated, and this is a similar version that was later proposed by Bohr, but the distinction really doesn't matter for us. The EPR experiment has meanwhile actually been done many times, so we know what the outcome is. And the outcome is that if you measure the spin of the particle on...
This is the EPR experiment? I didn't know that.
One side, then the spin of the particle on the other side has the opposite direction. Okay, I see you are not surprised, because we knew this already, right? So what is the big deal?
What are you talking about? Of course I'm surprised. I'd like you to explain it. What do you mean, what is the big deal? Explain it! Why not explain it? It's such not a big deal. Can you explain it?
Indeed, at first sight, entanglement does not appear particularly remarkable because it seems that you can do the same thing without quantum anything. Suppose you take a pair of shoes and put them in separate boxes. You don't know which box contains the left shoe and which the right shoe. You send one box to your friend overseas. The moment the friend opens their box, she will instantaneously know what's in your box. That seems to be very similar to the two particles with total spin 0. But it is not, and here's why. Shoes do not have quantum properties, so the question which box contained the left shoe and which the right shoe was decided already when you packed them. The one box travels entirely locally to your friend, while the other one stays with you. When she opens the box, nothing happens with your box, except that now she knows what's in it. That's indeed rather unsurprising. The surprising bit is that in quantum mechanics, this explanation does not work. If you assume that the spin of the particle that goes left was already decided when the original particle decayed, then this does not fit with the observations. The way that you can show this is to not measure the spin in the same direction on both sides, but to measure them in two different directions. In quantum mechanics, the spin in two orthogonal directions has the same type of mutual uncertainty as the position and momentum. So if you measure the spin in one direction, then you do not know what's with the orthogonal direction.
Okay, but how is this not the same as classical? Because in classical, right, with shoes, okay, so your analogy was not good. Okay, So the analogy wasn't good. But are you going to explain it?
This means if you on the left side measure the spin in up-down direction and on the right side measure in a horizontal direction, then there is no correlation between the measurements. If you measure them in the same direction, then the measurements are maximally correlated. Where quantum mechanics becomes important is for what happens in between, if you dial the difference in directions of the measurements from orthogonal to parallel. For this case, you can calculate how strongly correlated the measurement outcomes are if the spins had been determined already at the time the original particle decayed. This correlation has an upper bound, which is known as Bell's inequality. But, and here is the important point, many experiments have shown that this bound can be violated, and this creates the key conundrum of quantum.
Why is there an upper bound? They just say, oh, it has an upper bound. Why? Why would it have an upper bound? Why would it have an upper bound?
Mechanics. If the outcome of the measurement had been determined at the time that the entangled state was created, then you cannot explain the observed correlations. So it cannot work the same.
I can give you 100% correlation. 100% correlation. I don't get it. What more correlation do you want than this? What more? Show me what more you can produce. I mean, I track the data. This is the data. What more do you want?
Same way as the boxes with shoes. But if the spins were not already determined before the measurement, then they suddenly become determined on both sides the moment you measure at least one of them, and that appears to be non-local. So this is why quantum mechanics.
What? What is she talking about? What are these people always talking about?
Quantum mechanics. If the outcome of the measurement had been
Wait, I'm not sharing the whole thing. I'm wasting valuable space. Okay.
determined at the time that the entangled state was created, then you cannot explain the observed correlations.
Can you prove it? Or are you just gonna assert it? She's just asserting. She's asserting Bell's inequality. At least now I know when I debate people what they're talking about. People repeat this nonsense, this assertion. They just repeat the assertion. It's an assertion. Oh, you cannot repeat the same correlations as. What do you mean I cannot repeat the same correlation? What correlation do you want me to repeat? Tell me the correlation I need to repeat.
So it cannot work the same way as the boxes with shoes. But if the spins were not already determined before the measurement, then they suddenly become determined on both sides the moment you measure at least one of them, and that appears to be non-local. So this is why quantum mechanics is said to be non-local, because you have these correlations between separated particles that are stronger than they could possibly be if the state had been determined before measurement.
That's just an assertion. Bohm, not Bohr. Locality means that to get from. Okay. Mm-hmm.
Quantum mechanics, it seems, forces you to give up on determinism and locality. It is fundamentally unpredictable and non-local. Okay, you may say, cool, then let us build a transmitter, forget our frequent flyer cards, and travel non-locally from here on. Unfortunately, that does not work, because while quantum mechanics somehow seems to be non-local with these strong correlations, there's nothing that actually observably travels non-locally. You cannot use these correlations to send information of any kind from one side of the experiment to the other side. That's because on neither side do you actually know what the outcome of.
All right, so this is again Dirac's notation. On the left, it could either be up or down. The right could either be up or down. Mm-hmm.
These measurements will be if you choose a particular setting. You only know the probability distribution. The only way you can send information is from the place where the particle decayed to the detectors, and that is local in the normal way. So oddly enough, quantum mechanics is entirely local in the common meaning of the word. When physicists say that it is non-local, they mean that particles which have a common origin but then were separated can be stronger correlated than particles without quantum properties could.
What do you mean stronger? I can give you 100% correlation using either a hidden variable. I don't even need a hidden variable. I can give you this even without a hidden variable. Let's remove remove randomness. No more self-randomness. So instead of self-randomness, right, there's no probability here. There's no randomness here. So I'm going to create randomness. Let's remove self. So let's just create randomness. Randomness is equal to NP. And there's no autocomplete with this thing? Random is it random rand? But I want to give it, how do you add, oh, rand, loading. Why is it loading so long? I want to give it the seed. So random node create an array. What? How is the random number uniform? Okay. Let's copy this line. Oh, this number, that's good. Random value. Let's remove this. I can't see this. Oops, what did I just do? Okay, spin should be enough. And then, so, random value or randomness is equal to this value. Random value, but I want to give it the seed. Can I give you the seed? There's no seed. The spin, the self-spin angle. Would this work? No. How do you give it the seed? I want it to, let's take this guy. With seed. And in NumPy, seed is a function used to set the seed for the random number generated. This allows you to reproduce the same sequence NP random seed. Okay. But it's going to be a global variable. Yeah, but this is not multi-threaded. So NT random seed, exactly. That's exactly what I wanted. And then I'm going to create a number between 0 and 1 and use it. So each mhm. No? Cannot cast scalar from data type float to data type int according to the rule safe. Float to int? Why would, how can the seed at once, okay. Um, no, no, they can't because they each have a different spin, and they don't, like, one of them would have to invert the spin in order to create the same seed. So this cannot work. One of them has to invert the seed or invert the spin. So one of them has to know that it is 1, the other one has to know that it is 2. One of them has to know that it is the other one. Like they're, you cannot have symmetry because you want the same randomness. You can't use the spin as the seed because they would have different randomness and they would become uncorrelated. You would lose the correlation, so you can't. So you can't use no. So you need an outsider needs to, upon creation, it doesn't matter. I mean, so you need a hidden variable. That's fine. I don't care that you need a hidden variable. So go back. Mm-hmm. Mm-hmm. So go back to 180. And that's it. It's 100% entangled. And if you go to 90 degrees, it gives you the 50%. That's actually 50%. This says when the left particle 1 is up, then particle 2 is also up, but that's only 50% of the left being up. There's another 50% that the left is up, and in that case the right or the particle 2 is down. So it's 50-50. So this reproduces the data precisely. And if you do 45 degrees, it's whatever you want. Whatever the ratio you want it, whatever the data is, tell me what the data is, and this depends already on the actual mechanics of how it works. Right? The question is, do we need telepathy? Or do we have an alternative explanation other than telepathy? So this gives you, right? You tell me what correlation you want. But I don't think we're even arguing about that. Um, so at 45 degrees, they're up, and some of the time particle 2 is up, but most of the time it's down, it's opposite. Right, because at 90 degrees it's 50-50. 45, they're almost correlated to give the same direction. It's close to zero. At zero, they're supposed to give the same direction. Up down is actually the same direction. That's because it's a little confusing. Mm, let me see. Why is it so confusing? Result A, result B, they don't know the difference, so they should give the same. A and B should be the same. So A and B are up and up, it's up and up. At 0 degrees, they should be saying up and up. So this is exactly the opposite, isn't it? They should both be up, shouldn't they? No. No, at 0 degrees, they should be 180 they should be opposite, right? Because they spin in opposite directions. The fact that we're measuring in the same direction, we're measuring in the same direction, but the spin is always opposite. Right? You can, right? This is opposite spin. Here is the opposite spin. The spin is opposite. So everything is perfect. Everything is according to plan. Everything is explained.
Could ever be. I know this sounds somewhat lame, but that's what quantum non-locality really means. Having said this, let me add a word of caution. The conclusion that it is not possible to explain the observations by assuming the spins were already determined at the moment the original particle decays requires the assumption that this decay is independent of the settings of the detectors. This assumption is known as statistical independence. If it is violated, it is very well possible to explain the observations locally and deterministically. This option is known as superdeterminism, and I will tell you more about this some other time. That's it for today. Thank you for watching. See you next week.
I didn't get that. That if the direction is not known at the time of the creation, I don't need to know anything. I don't care. I mean, you can right, in my case, in this code, I create the particles and everything is already set in motion. That's it. They're baked. Sorry, here. The particles are baked. The particles will never change. It's done. And now you can set whatever measurement angle you want. I mean, it happens to be that the measurement angle is always 0, but you can run this experiment with any two angles. Nobody cares. This just reproduces Don Lincoln's experiment. I don't want to get involved with writing code. This is not my. I don't care about that right now. No. I'm gonna let ChatGPT write the code. We're not trying to write code. We're trying to prove maybe the most important thing in the world right now, that there is no mysticism.
Were separated can be stronger correlated than particles.
I mean, that entanglement is mysticism.
without quantum properties could ever be. I know this sounds somewhat lame, but that's what quantum non-locality separates, and what the outcome of these measurements will be if you choose a particular setting. You only know the probability distribution. The only way you can send information is from the place where the particle decayed to the detectors, and that is local in the normal way. So oddly enough, quantum mechanics is entirely local in the common meaning of the word. When physicists say that it is non-local, they mean that particles which have a common origin but then were separated can be stronger correlated than particles without quantum properties could ever be. I know this sounds somewhat lame, but that's what quantum non-locality really means. Having said this, let me add a word of caution. The conclusion that it is not possible to explain the observations by
I don't understand what she's talking about. I honestly have no idea what she's talking about. I'm baffled. I mean, she's just asserting. She didn't prove anything. She's just asserting that quantum mechanics, what they call quantum mechanics, is more correlated than hidden variable. That's just an assertion. That's Bell's inequality. Bell's inequality is just an assertion. I can give you 100% correlation. What would stop me from giving you 100% correlation? What more do you want? What more correlation do you want? What more correlation do you want? This is 100% correlation. I cannot give you more correlation than that.
assuming the spins were already determined at the moment the original particle decays, requires the assumption that this decay is independent of the settings of the detectors. This assumption is known as statistical independence. If it is violated, it is very well possible to explain the observations locally and deterministically. This option is
Right. She says that if you we need in order to have statistical independence, you at the time of the creation of the particles, the direction of the measurement should still be unknown. And only after the particles have been created and maybe even sent on their ways to the detectors, only then should you want to delay the choice of the direction of the measurement to as late as possible to have statistical independence. Fine, I don't care. I don't care. I mean, you tell me what you want and I'll create it. Whatever you want, I'll create it. And that is the alternative theory to whatever magical thinking you have.
known as superdeterminism, and I will tell you more about this some other time. That's it for today. Thank you.
I don't know what she means by superdeterminism.
They want reality to be weird because they like the mystery. There are several hidden variables models that are local and that reproduce the predictions of quantum mechanics by violating measurement independence. I'll leave you links in the info below. And yes, a violation of measurement independence has also been called superdeterminism, though this term is extremely misleading.
Violation of measurement independence? What?
Links in the info below. And yes, a violation of measurement independence has also been called superdeterminism.
I don't know what is a violation of measurement independence.
Though this term is extremely misleading. I talked about this in an earlier video. In summary, quantum mechanics is not local. What makes it non-local is the collapse of the wave function. The question is whether this non-locality is physically real. If the collapse of the wave function was a physical process, it would be what Einstein called a spooky action at a distance, and reality would be non-local. It has not been shown that this is indeed the case, no matter how many headlines say otherwise. Entanglement is a non-local correlation that can stretch over long distances, but it's not what Einstein meant by action at a distance because there's no action in it. If you're a fan of the many words interpretation of quantum mechanics, you probably took issue with some things I said, but this video is already too long, so I'll talk about this some other time. If you want to hear me complain about many words, don't forget to subscribe. Yes, I admit there's a lot going on in this video that I only touched on very briefly. What is a wave function? How do you get probabilities out of it? How does interference work? And why is it important? If you want to understand this in more depth, you can do this.
Interference? Where was interference?
It's with my course on quantum mechanics at brilliant.org, who have been sponsoring this video.
So she's still promoting the same course. So I don't think she changed. I don't think she thinks she changed her mind. I don't know what her position is. I'm so confused.
Brilliant offers courses on a large variety of subjects. I'm sure you've read that some. Quantum mechanics is weird. I'm sure you've read that somewhere. And why is it weird? Oh, it's because it's got that spooky action at a distance, doesn't it? Einstein said that. Yes, that guy again. But what is spooky action at a distance? What did Einstein really say? And what does it mean? That's what we'll talk about today. The vast majority of sources on the internet claim that Einstein's spooky action at a distance referred to entanglement. Wikipedia, for example. And here is an example from Science magazine. You will also find lots of videos on YouTube that say the same thing.
Hey. So she disagrees with Don Lincoln, too. With the video that started everything for me. Interesting.
Einstein's spooky action at a distance was entanglement. But I do not think that's what Einstein meant. Let's look at what Einstein actually said. The origin of the phrase spooky action at a distance is a letter that Einstein wrote to Max Born in March 1947. In this letter, Einstein explains to Born why he does not believe that quantum mechanics really describes how the world works. He begins by assuring Born that he knows perfectly well that quantum mechanics is very successful. I understand, of course, that the statistical formalism which you pioneered captures a significant truth. But then he goes on to explain his problem. Einstein writes, I cannot seriously believe in quantum mechanics because the theory is incompatible with the requirement that physics should represent.
Oh, I felt like she's speaking suddenly with a heavy German accent. I cannot seriously believe in quantum mechanics because the theory is incompatible with the requirement that physics should represent reality in space and time without spooky action in the distance. But what is he referring to?
Reality in space and time without spooky action at a distance. There it is, the spooky action at a distance.
Ich kann aber deshalb nicht ernsthaft daran glauben, weil die Theorie mit dem Grundsatz unvereinbar ist, da, I don't know what this, die Physik eine Wirklichkeit in Zeit und Raum, Raum, that's room, or Rome. That's like distance, maybe. Darstellen soll on spukhafte Fernwirkungen. Well, this is spooky, spukhafte. Where's action? Wirk? Where's the distance? I don't know.
But just exactly what was Einstein referring to? Before we get into spooky action at a distance. There it is, the spooky action at a distance. But just exactly what was Einstein referring to? Before we get into this, I have to quickly remind you how quantum mechanics works. In quantum mechanics, everything is described by a complex valued wave function, usually denoted psi. From the wave function, we calculate probabilities for measurement outcomes.
That's already complete and utter nonsense. You don't need the wave function. Why are you bringing in the wave function? Wave function is to describe how waves wave, that everything is a wave. Why do you need to bring it up?
For example, the probability to find a particle at a particular place. We do this by taking the absolute square of the wave function.
No, a wave function has nothing to do with a particle, so you're welcome. Roll the credits.
But we cannot observe the wave function itself. We only observe the outcome of the measurement. This means, most importantly, that if we make a measurement for which the outcome was not 100% certain.
The fact that you claim that you cannot observe the wave function, that's already incorrect. There's many ways to observe the wave. There's many experiments we've done to show that an electron is a wave. There's many. We can sending an electron through a double slit, it interferes with itself. It goes through two slits at the same time. That makes it a wave. That's an indication that it's a wave. And all the experiments, the fact that there is that hydrogen, the hydrogen lines, and the fact that every element has its spectrum, whatever, the spectral lines, every element has its spectral lines. How do you explain that? The only explanation is that the electron is a wave when it's orbiting the nucleus. Bohr explained it, and then Sommerfeld, and then de Broglie. De Broglie put the nail in the coffin that the electron is a wave. After that, and then Schrodinger. And that's it. Schrodinger couldn't disagree more with what you're saying right now. Schrodinger disliked this interpretation of the wave equation, of the wave function.
then we have to suddenly update the wave function. That's because the moment we measure the particle, we know it's either there or it isn't. And this update is instantaneous. It happens at the same time everywhere, seemingly faster than the speed of light. And I think that's what Einstein was worried about, because he had explained that already 20 years earlier in the discussion of the 1927 Solvay conference. In 1927, Einstein used the following example. Suppose you direct a beam of electrons at a screen with a tiny hole and ask what happens with a single electron. The wave function of the electron will diffract on the hole, which means it will spread symmetrically into all directions. Then you measure it at a certain distance from the hole. The electron has the same probability to have gone in any direction. But if you measure it, you will suddenly find it in one particular point. Einstein argues, the interpretation according to which the square of the wave function expresses the probability
The square of the wave function expresses the probability that this particle is found at a given point assumes an entirely peculiar mechanism of action at a distance, which prevents the wave continuously distributed in space from producing an action in two places on the screen. Yep. That's something that I don't have an answer to. Because how does the electron know to show up as a particle in one spot on the screen and not in any other spot? How? I don't know. I personally, I don't know. I didn't. I need to see the experiment. I need to see the apparatus. I need to do a deep dive into that. I don't know. I don't know how that happens. That is a good question. But so far, everything else that I looked into, it's a nothing burger. So for now, I don't know. I'm open-minded. I don't know. Everything else, nothing burger. And I've looked into almost everything.
that this particle is found at a given point assumes an entirely peculiar mechanism of action at a distance, which prevents the wave continuously distributed in space from
Let's see if she understands it, because I came to the same conclusion without ever knowing that he said this. This has bothered me for a very long time. Let's see if she understands it the way I understand it.
producing an action in two places on the screen. What he is saying is that somehow the wave function on the left side of the screen must know that the particle was actually detected on the other side of the screen. In 1927, he did not call this
Exactly. Yeah, she understood it. So me, her, and Einstein agree at least on that.
action at a distance spooky, but peculiar. But I think he was referring to the same thing. However, in Einstein's electron argument, it's rather unclear what is acting on what, because there is only one particle.
It doesn't matter. I mean, but it is, yeah, that is this instantaneous collapse. I don't call it even a collapse of a wave function. I just call it the collapse of the wave, because in my interpretation, the electron is legitimately a wave. But how does it know to collapse to one dot and not nowhere else on the screen? I don't know how it does that, but it could be a physical mechanism that. Oh, we have a visitor. Hello.
Oh, you're speaking to someone else?
No, I'm streaming on YouTube. How are you? Do you want to talk about? Oh my God. People don't like being recorded, especially chicks. Chicks hate being recorded. Unbelievable.
Particle. This is why Einstein, together with Podolsky and Rosen, later looked at the measurement for two particles that are entangled, which led to the famous 1935 EPR paper. So this is why entanglement looked at what is acting on what, because there is only one particle. This is why Einstein, together with Podolsky and Rosen, later looked at the measurement for two particles that are entangled, which led to the famous 1935 EPR paper. So this is why entanglement comes in, because you need at least two particles to show that the measurement on one particle can act on the other particle. But entanglement itself is unproblematic. It's just a type of correlation, and correlations can be non-local without there being any action at a distance. To see what I mean, forget all about quantum mechanics for a moment. Suppose I have two socks that are identical, except the one is red and the other one blue. I put them in two identical envelopes and ship one to you. The moment you open the envelope and see that your sock is red, you know that my sock is blue. That's because the information about the color in the envelopes is correlated, and this correlation can span over large distances. There isn't any spooky action going on here, because that correlation was created locally. Such correlations exist everywhere and are created all the time. Imagine, for example, you bounce a ball off a wall and it comes back. That transfers momentum to the wall. You can't see how much, but you know that the total momentum is conserved. So the momentum of the wall is now correlated with that of the ball. Entanglement is a correlation like this. It's just that you can only create it with quantum particles.
So 3 years ago, she already agreed with me today. I don't think she ever changed her mind, but I don't understand. I mean, she talks the way she talks. It's as if she believes in some weirdness, but where's the weirdness? I don't know where's the weirdness. I guess the fact that there is a hidden variable.
Suppose you have a particle with total spin 0 that decays in two particles that can have spin either
Okay. So it's pretty clear. Yeah. So the conclusion is there is a hidden variable. So every particle has just another parameter that no one mentioned, the hidden variable. But Einstein never spoke about it. Einstein never said, let's add this to every variable. Every variable has a memory. This means every variable has a memory, or it has another quantum state that we're not tracking.
plus or minus 1. One particle goes left, the other one right. You don't know which particle has which spin, but you know that the total spin is conserved. So either the particle going to the right has spin plus 1 and the one going left minus 1, or the other way around. According to quantum mechanics, before you have measured one of the particles, both possibilities exist. You can then measure the correlations between the spins of both particles with two detectors on the left and on the right side. It turns out that the entanglement correlations
I think she believes entanglement is mechanical, but she believes superposition is real. I think she believes in the superposition mysticism, in the superposition myth.
can, in certain circumstances, be stronger than non-quantum correlations.
Maybe Einstein believed that too, and that maybe confused everyone. I don't know.
That's what makes them so interesting. But there's no spooky action in the correlations. So mechanics, before you have measured one of the particles, both possibilities exist. You can then measure the correlations between the spins of both particles with two detectors on the left and on the right side. It turns out
Why are the two detectors different?
that the entanglement correlations can, in certain circumstances, be stronger than non-quantum correlations.
I don't know what she just said. This thing with the stronger, and look at the emoji. I don't understand. I mean, can you please explain? What are you talking about? I just don't understand what she's talking about. Could be that what? Something is stronger than something? Be stronger than non-quantum? What is non-quantum correlations? What is a quantum correlation? Hello? Yes, hello?
Hey, what's cracking?
What's cracking? What's up? Do you want to talk about quantum
It's a
entanglement?
nice,
What?
I
Mm-hmm. Yes?
don't know. How intense is this about to be? It's 2 a.m. where I am at.
It's 2 a.m. Let me think if it's Australia.
No, Canada.
Canada, it's 2 a.m.? How?
Yeah,
Oh, you're on the Pacific. You're Alaska.
I'm on the west side. No, I'm in Alberta.
I mean, close. That's on the side of Alaska. I mean, that side of the planet. So you're very close to Australia. Your time zone. Your time zone is like a couple of hours away from Australia.
I don't know.
I mean, you're on the
I don't
west.
know.
Look, you're on the west coast, right? You're very close to Russia and China, right? From you
Yeah,
to
we're pretty close to Russia. We're actually we're way closer to Russia than most people really contemplate.
like what? It's a 4-hour flight to Beijing.
I don't know.
Yeah, I mean it's pretty close. I mean it's basically a local flight. I mean
It's decent.
you probably have a 10-hour flight or so to Florida, to Miami, or maybe 7-8 hour flight. I would say. Like I think you have a longer flight to Miami than you have to Beijing, but it doesn't
I
matter.
don't know.
Yeah, I don't know. So, what do you know about entanglement? What do you know about quantum mechanics? What do you know about physics?
There was a chick named Dr. Lisa Pecurioli. She got a mathematics grant called the Mathematics Breakthrough Prize.
Mm-hmm.
Or no, it was, I don't know, it was one of them.
Mm-hmm.
Oh yeah, no, it was the mathematic. Actually, you know what? I
Mm-hmm.
have the link. I have relevant information. Actually, this is actually going to be pretty decent.
Mm-hmm.
Here, there you go. There's the first link. So that's the breakthrough prize she got. She's the third person on that list.
Mm-hmm.
She talks about 4D geometry,
Mm-hmm.
and she's like one of the people who are on the cutting edge regarding the discussion and the understanding of 4D geometry. She had a YouTube video. Here's the YouTube video.
Mm-hmm. She hot?
Yeah, she's all right. She's decent.
Mm-hmm.
So that's the YouTube video of her talking about
It's my pleasure to
4D
introduce
geometry. So
the
she actually discovered something in mathematics
Oh, she's super
relevant.
hot. She's really hot.
Yeah, she's not bad. She's
Wait, let me see.
well, what's interesting is she's really young, right? So she's dealing with basically what is the leading edge mathematics that we use in GPUs and stuff like that.
Mm-hmm.
And she's like in her 20s or 30s.
She's Italian.
So like went to a Latin school, and it was a Jewish guy runs the fund that gave her some of the money.
Mm-hmm.
It's like a Jewish thing,
Mm-hmm.
Latin school, Jesuit thing. I don't know how familiar you are with all
I'm
those
not.
communities, but
No idea. Anyway, so
they're really.
But what's your opinion? Okay, fine. I mean, but what's your opinion? Where do you stand on this issue?
Oh, I think they're going to look into four-dimensional spaces and
Four-dimensional space. Oh, I'm sorry. That's just normal life. I mean, 3 dimensions plus time. That's life. That's our universe. There's nothing peculiar about that. Four
yeah, but it's
dimensions.
like
4 dimensions is just general relativity. That's what you're used to. It's just that as a 4-dimensional vector, it's easier. The math becomes easier if you treat time like another dimension, like a 4th dimension. It's just a convenience. It's called Minkowski geometry, Minkowski spacetime. It's Einstein's professor who came up with it. And Einstein in the beginning rejected it, and then he fell in love with it. And he used it to derive general relativity. There's nothing interesting about 4 dimensions. I mean, it's interesting, okay, but where do you stand on entanglement? I mean, mapping reality into some vector space, into some Cartesian or Riemannian space. I mean, fine, you can map reality into whatever you want, but what do you think about reality? So, do you know anything
I
about?
don't know. I'm Christian, so that's my view on reality.
Oh, so you're a mystic. You believe in mysticism.
Yeah.
Why?
Hesychast level Christian, like Orthodox.
I don't know what that is, but I never heard the words hesychast. What is hesychast?
It's like a monastic practice.
I don't know what monasticism is. I've maybe heard this term once.
It's like some of the stuff that the monks do, right? So there's like types of prayers.
Mm-hmm.
They affect you differently.
Mm-hmm.
Okay. So and then their argument is there's a spiritual difference in the effect, and there's a literal emotional difference in the effect, which we can measure the different effects, but the only reason they're doing it is for the spiritual reasons.
Mm-hmm. Okay. So why did you adopt this belief? What's the purpose of adopting this belief?
Oh, I can't even explain it to you. I've just seen some crazy weird shit.
Like
so
what?
I'm a convert.
Okay. Convert
I
from
can't
what?
explain it.
Where did you start?
I was an atheist for a long time. I can't even explain it. There's no way to explain it in English.
Why? How can you know?
Because English, I don't know. It's just English is not like from an like
Mhm,
I guess I've contemplated it,
mhm.
but like from a linguistic standpoint, to explain the experiences that I've had that led me to my beliefs,
Well,
English is not a suitable language to explain it. Like we need a
Mhm.
better form of communication to properly convey the experience that I've had that led me to that belief.
I mean, so it sounds like you're running away from from discussing it. It sounds like you don't want to discuss it.
I mean, I can discuss it. It's just it's not. It's just going to be the same rhetoric that you've already heard. I'm sure there's no way to properly explain it. Like there needs to be a better form of communication. Like English and
Mhm,
and
mhm,
our vocal boxes are
mhm,
not effective enough information translators
mhm,
or communication devices to properly convey
mhm,
the series of circumstances that led to that belief.
mhm. It sounds like you live a life of lies. That's what
No,
most.
no, it was definitely real. That's the problem.
Then look, you should be able to discuss it. You should want to analyze it. You should want, like, if you don't want to live a life of lies, you should always.
I don't.
Mhm,
I mean, like, yeah, I've tried to analyze
mhm,
some of what has occurred, but
mhm, mhm,
it's like it's not really fully analyzable because it's like imagine
mhm,
you're a fish that gets taken out of the water
mhm,
and gets explained how stockbroking works,
mhm,
and then you get put back in the water,
mhm,
and now you want to explain to your fish friends why
mhm.
they should invest in the NYSE. Like it's just not possible. It's not the
Wait, I lost you.
communicating with other fish to properly convey what he's talking about. And so he's just talking about leaving the water
Okay,
and
one
it being
second.
important, but it's
Okay,
just not.
all right. I personally don't like analogies. Like, people, we can get lost in analogies, and that's not productive in my opinion.
Yeah. The problem here is the English language and vocal communication is not effective enough for me to convey the experiences that I've had and how they've affected me. It's not a proper communication medium. There needs to be, really, to solve this problem,
Wait,
we need to invent a better medium for communicating between humans
wait,
so that I can properly convey that information.
wait. One second. I told you already. It sounds like you're living a life of lies. What you're saying is, I don't want to talk about it, right? When somebody says I don't want to talk about it, right? Why would you not want to talk about something?
It's not that I don't want to talk about it. Like it was so significant that I did talk about it for a long time. But like I've found that to properly explain it, it's like I just can't communicate it efficiently or effectively enough. But it was
Hmm.
from, if you're going to look at it solely from a logic standpoint,
Hmm. Hold on.
here's the
Wait,
series of events that I would describe.
okay,
There was a set of circumstances that occurred
wait.
that changed my human behavior
All right, hold on.
forever.
Okay, wait,
And because that set of circumstances that occurred that
wait,
changed my behavior forever
wait, one
can't be
second.
conveyed properly, it's
Wait,
just people ask, why is your behavior changed? And
wait,
it's like, I
wait,
can't.
wait. Hi, Ventus. Anyway, look, What are you talking about? You keep talking about something that happened and events, but you're not talking about the events. You're only talking about the events, and you're only saying I cannot talk.
Yeah, it's like a series. Well, it's not an event. It's what I would describe as a series of events, a series of coincidences, a set of circumstances, a a hmm, a symbolic interpretation over the course of a lengthy period of time, which
Okay,
I would
I'm
say
lost.
was probably a few
I'm losing
years.
you. I'm losing.
And that symbolic
I'm
set of
losing.
interpretations over a period of a few years,
I don't know
like
what
it's not
I don't know what
properly
that means.
conveyable. Like
I
I
don't,
can't
I
convey
don't
it.
know. I don't know what it means. I don't even know what you just said.
Yeah, that's see what I mean? Like I can't properly convey what I'm talking about here because English and vocal communication
No.
is
Stop.
not effective enough for me to
Stop.
talk
No,
about what I'm talking about here.
no. That's called obfuscation. I could also do that. I could also talk and make no sense. That's just lying with extra steps.
Okay, well, the reality is there was a circumstance which led to a literal behavioral change that had manifested that you can see in me to this day. And that
Okay.
behavioral change
Mhm.
occurred
Mhm.
because something happened.
Mhm.
But whatever happened, I
Mhm.
cannot convey in English words. It is not possible for me to explain to you
Mhm.
why my behavior has changed. It's
Mhm.
not possible to do it in English or using my vocal cords.
Mhm.
Otherwise, I'd be able to communicate it properly and it would immediately change your behavior, no different it is as it has changed mine.
Okay. So what? So you're telling me that something happened. So you had some experience or a set of experiences that changed your behavior, and you cannot explain how A caused B. So A is the set of events, set of circumstances, and B is your behavior. And A caused B, but you cannot explain how A caused B. Is that what you're saying?
Yes, I can explain B
Mhm.
and I can evidence B, but I cannot communicate A. And I believe A
Wait, what do you mean you cannot?
was
What do you mean you cannot communicate? I don't understand when you say I cannot communicate.
because if I was capable of communicating A and conveying that
Well, why don't
information
you? Well,
properly,
why don't you try? I mean, I don't know what it means you can't.
I'll just sound crazy. I'll just sound crazy. The
So
reason I don't try anymore is because when it happened, I did it for like a whole bunch of time. But
try. Let's try. Hit me with your best shot. So tell me about it. What
oh, I
happened?
don't even know where to begin. Like that's what I mean.
No,
Because
go.
what it was it wasn't a period in time
Mhm.
that was like it wasn't like a 1 day 24-hour period thing. It was like a few minutes
Okay, let
or
me
a
ask
couple
you.
hours.
Hold on. So you believe in a mystic, right? You believe in Jesus, for example, right?
Yes.
Okay. All right. So, as far as I know, everybody agrees Jesus was a guy who lived on Earth for a short period, a couple of years ago, thousands of years ago, in the ancient land of Judea or whatever.
Yes, it
No
was
one,
along the Jordan River.
okay, no one debates that. And he went to Jerusalem and he got into a dispute with the priesthood, and they,
Yeah, like he physically existed. And I think the history, like the
okay,
spiritual thing can of course be debated, but Jesus like physically
okay,
existing as
so
a human who interacted with
that's fine.
politics, I
Okay,
think that's undebatable.
okay, all right. So, as far as I know, he was a proto communist. He was against the bankers. He didn't like banking and he overturned the bankers' tables. That's
Much
like
more
one of the.
complicated than that.
It's more complicated than that. Okay, what do you mean?
I would argue that the purpose, or one of the major cornerstones of the purpose of behaviors that he displayed, which includes overturning bankers' tables, speaking out against religious leaders at that time, the argument I would make is he did it in such an effective demeanor that it self-evidences a capacity for some kind of
Okay, it doesn't matter. I don't care.
some kind of like psychological future reading prophetic capacity.
Yeah, a lot of people are against money and against banking and finance. There's nothing new. He didn't have a new message. I personally love banking and I love finance, and people like Jesus that hate banking and finance and bankers, to me they are communists and they are the worst.
What's the behavior? He didn't.
To me, these people are the worst possible. To me, these are North Korea. When I think of North Korea and I think of Jesus and overturning bankers and being against banking and interest and finance and money.
He wasn't against currency.
Okay, it doesn't matter. The point is, to me, it's as evil as evil can be. To me, Jesus is evil. The Jesus philosophy, the Jesus communism, that is pure evil. I mean,
there's information you don't know, would be my argument.
Anyway,
and that information is very pertinent.
It doesn't matter. It doesn't matter. The ideology, I mean, Jesus was a young person, and a lot of young people, me included, in the beginning, we think, communism is the best thing. When we first hear of communism,
it was about 35. It was 35-ish.
It's fine.
You know,
it's fine.
40-ish.
It's fine. Anyway, people in my early years, I used to be a communist, but then I actually slowly started studying economics, and I realized that communism leads to North Korea. Communism is the end of civilization. So the message that Jesus gave humanity is the worst message possible.
No, terribly incorrect is my argument. This requires further analysis. It's not about communism, what he did. There's something. The problem is there's a piece of hidden information in the narrative, in the storyline, that displays a very intellectually high-level sociology education.
Why do you talk in such a obfuscated way? It's like you're always talking. I'm always trying to understand what you're trying to say, and it's like you're trying to obfuscate instead of, like, as I told you in the beginning, it sounds like you live a life of lies. You're always.
No, it's just I'm trying to convey complicated topics without being disingenuous and putting in.
There's nothing complicated about Jesus and about religion and about Christianity.
It's much more complicated, is my argument.
There's nothing complicated.
Then my argument is it's much more complicated.
Yeah. You seem to purposefully try to obfuscate this discussion instead of simplifying the discussion in order to have a discussion, in order to.
I can't simplify it. You're correct.
Fine.
I can't simplify it.
Okay.
I wish I could.
No, you're trying to obfuscate. You're trying your hardest to come. Every sentence you're saying, you're trying your best to complicate. You're just a liar.
No.
Yes,
I'm not a liar.
Yes,
you are.
Yes, you are.
I was wholly honest with you in the beginning of this, that this is a piece of information I can't convey in English. And that's why I didn't want to discuss it.
That's a complete.
And you enticed me to discuss it, and here we are. Now we disagree. You see my problem here?
Okay, I mean, you want to live a life of lies and consider yourself to be holier than thou.
It's not a life of lies.
Yes, it is.
Jesus Christ was telling you the truth.
What?
But it's much more complicated than just a sentence or two.
I spared you to waste my time about what Jesus Christ told me. Jesus Christ was a commie, and I hate commies.
He's not a commie.
Yes, he is.
He's not a commie.
He's against banking. He's against money. Look,
he's not against banking.
To me, yes,
He's not
he
against
overturned.
banking.
Okay, he overturned the bankers' tables, the money exchangers.
He was against that banking institution. He was not against currency or capitalism.
Fine. Look, it's enough. I heard his message loud and clear. I hate his message, and I hate the messenger. He was an idiot.
You shouldn't hate his message.
Well,
he's not an idiot. He had a good message.
Well, no, it's a terrible message. This is the message that ends up with North Korea. This is how you destroy a civilization. So I hate the message.
Yes. He's had his institution he created as a byproduct of what he did has lasted 2,000 years. How many other institutions have lasted 2,000 years?
I don't care. I'm talking about his message.
That's reasonable and factual information.
I don't care. I didn't say it's not. I just don't
care. Then you should take it into account. Otherwise, you're missing information.
It's irrelevant. It's completely irrelevant.
It's much more relevant than you're not prioritizing the information correctly. Then
why should I care that he created an institution? Why should I care? He gave us a message that I think is literally the worst message possible. And he wasn't even an original. A lot of thinkers are communist. Even Einstein was a communist.
So his major predecessor, and I wouldn't necessarily call it a predecessor, but the people with the same ideas which were previous to him, there's a guy named Melchizedek who specifically spoke about giving 10% of your income to him. Melchizedek is a guy you would be interested in, especially on the discussion of communism.
I don't care.
Because of his specific discussions on 10% of your income.
I don't care. Look.
It's to understand what Jesus Christ was doing.
I understand Jesus perfectly. I disagree with Jesus.
I don't believe you understand it. You're refusing to read about Melchizedek. How can you understand the institution that Jesus Christ was trying to build if you're not reading about his predecessors or the history of the institution?
Okay, look. Jesus's message is 180 degrees from what I appreciate. It's the opposite of what I think is good. Jesus, to me, was pure evil. But,
no,
to me.
Pure good.
Yeah, to me.
Pure good.
No, to me, no.
And to me, he's pure good.
Well, I used to be a communist, so I used to think it's pure good. But now that I'm a capitalist, I think it's pure evil. I know where this ends. So Jesus was where I was a few years ago. I was a dummy dum-dum. I didn't know economics. I thought communism is the latest and best. I thought Mao and Stalin and all those guys and Che, they were just the best thing ever. But, I studied and now I know I was wrong. I was an idiot. I was a buffoon. Just as I think Jesus was a buffoon. And Jesus just ended up killing himself early on, so he never had a chance to grow out of this communist phase. But that's all he was.
He was killed by Romans for his opinion on their institutions. I think that merits investigation. And not only was he killed by the Romans for that, but there was predecessors who spoke about his coming as a Messiah, and Melchizedek was one of them. And his comments on essentially giving 10% of your income to him, Melchizedek, which at the time was more of it. Look,
the point is, okay. So look, our discussion is a completely technical discussion, and I don't see. I told you. I mean, I've been able to completely understand where you are, and there's
I
nothing.
disagree.
There's something I don't understand about your position.
I told you at the start of this it's really complicated, and I'm not going to be able to convey this properly.
Yeah, but
And
up
and
until
now
now,
we
there's
both
nothing.
disagree because
No,
of my
no.
inability to convey this properly.
Okay, so I've been able to follow the conversation, and the conversation is very simple and a very old conversation that I've had many, many times. And I explained to
You
you.
refuse to read up on Melchizedek.
Yes, I refuse to waste my time. That's correct. And there's
You
nothing.
should read up on
No,
Melchizedek.
and
It's
there's
relevant
nothing. There's
information.
nothing. There's nothing complicated. You're saying everything you're saying is extremely simple. You tried in the beginning to obfuscate, to hide the fact that you live a life of lies. Your religion is nothing but a life of lies, and you obfuscate that.
This is not true. This is not true.
Yes.
But I will say it is a very complex discussion on
No, it's not.
sociology.
No,
It is.
you're
It is.
obfuscating. You're
Is
like,
sociology
no, it's
not
not.
complicated?
It's so
this
simple.
topic.
No, your position is so simple.
Okay,
No,
so
you're
so
just
that's why
another.
people take 12-year
I don't care.
PhD
I don't
degrees in
care.
psychology
I
because
don't
it's so
care.
simple.
I don't care.
That is relevant, is it not?
I don't.
Is that factual?
Your
Is that
position.
not factual?
Your position is identical to everyone I've spoken to in the world that has a religious point of view. You're all trying, I mean, many of you try to obfuscate and not discuss or run away from a discussion. You think you're going to not run away from the discussion, but obfuscate. You just developed a new tactic of hiding your life of lies.
Does it take 12 years to get
I
a
don't care.
sociology PhD?
I don't care. I don't care. I don't care.
Yes or no?
I
Or
don't
are you
care.
obfuscating right now? Are
I
you
don't-
obfuscating right now?
Obfuscating. How is that relevant? How is that relevant? Whatever it takes, it takes.
Well, you
Look it up.
seem
Google
to be
it.
avoiding that question, huh?
Google
Just
it.
like me.
I don't know. I don't know, and I don't care.
You're doing the same thing as me now. That's all I'm saying.
I never told you anything is complicated. I keep telling you everything is simple. I don't think anything is complicated. Now, if you want to Google how long it takes to get a degree, Google it. Whatever Google says, I don't care. Either way, how does that
12
impact?
years to get a PhD
I don't
in
care.
sociology.
I don't care. How is it relevant?
That's relevant. That is a
Why?
relevant thing if we're going to discuss sociology and whether or not it's
Why would
complicated.
we want to discuss sociology?
Because you're saying that what I'm saying is irrelevant because of its complexities.
No,
and I'm
you
telling
said
that sociology
that's
as
your
a
position.
whole is extremely
No.
complex.
No,
So
that's your
quantum en-
position.
no,
You missed
so
what?
quantum entanglement. So quantum entanglement isn't real. It's a fake idea.
What do you mean?
It's not real. It's made up in our head.
What do you mean?
All right, I'm out.
All right,
Good
thank
run.
you, man.
Good
Yeah.
talk.
Yeah, good talk. Thanks.
Good day.
You too.
People who made quantum mechanics were on perks,
What?
drugs.
What?
People who made quantum mechanics were on drugs. So it's made up in our head.
I don't know what I mean. That's literally ad hominem. So you're attacking the people who came up with an idea because of them, because something they did. So if you want to debate quantum mechanics or entanglement, we need to
No,
debate.
quantum mechanics isn't real. It's impossible for it to be real. Because if it was real, many things would be happening. Like the Earth would be flat, and clearly the Earth isn't flat.
How is the Earth being flat a result of quantum entanglement?
Because quantum entanglement entangles, if you did not know this, gravity pulls towards the nearest pole, right?
What?
You know this from many.
What?
Listen. I'm gonna put this in dummy
Your
mode. Okay? I'm
audio.
gonna explain this.
You keep touching your mic and you're whispering into your mic, so I can barely.
Is this better, brother? Is it better?
You keep touching your mic. You're like making noises with your mic. So
Is it better now?
yeah. I mean, as long as you don't touch your mic, it's gonna be better.
Am I touching it right now?
Yeah. Yeah, I can hear. I can hear.
I'm gonna fix it. Okay, let me know when you're ready.
Okay.
Wait, I'm fixing it. Okay.
Yeah.
Wait, I'm fixing it. Okay.
You keep making
Is it better?
noise. I don't know.
Is it
I don't know. Just like every time you say, Is it better? And then you keep touching it again. So if you make
What
noise,
about now? What about now?
okay. So give it time. If in the again you're touching it, I think it's touching
I'm
your
done. I'm done.
clothes. Is it? It could be touching your
No,
shirt.
I'm done. I'm done. I'm done. I'm done. I'm done.
Anyway, what do you want
Ready,
to
brother.
say?
So
Hmm.
Earth would have to be flat because
Why?
ready?
Am I ready?
Because it says that gravity and
Hmm.
horizon. The horizon comes from gravity, and the horizon.
The horizon comes from gravity? What?
Yeah. You didn't know, like
What do you mean I didn't
reason.
know? What do you mean the horizon? How is the horizon from gravity? How is that
Because the
related?
reason the Earth is a ball, the
Okay.
reason the Earth is a ball
Uh,
is because of gravity, which has to do with the
yes.
horizon.
Okay.
So the horizon comes from gravity, and if
All
the
right.
horizon comes from,
Okay. Mhm.
understand?
Yeah. Go on. But
Right.
how?
So
But what about quantum
if
entanglement?
I'm gonna tell you, so if the
Mhm.
horizon
Mhm.
comes from gravity,
Mhm.
then that would
Mhm.
mean
Mhm.
you ready?
You touched your mic again. I'm ready. Go on. Stop touching your mic. Stop asking if I'm
Okay.
ready. Just talk, talk, talk. Okay.
Okay.
Look, you're really funny. Come
Okay.
on, let's go. Let's go. You wanna talk or you wanna say nonsense? You wanna just spout nonsense? What's your preference?
Okay. Quantum entanglement. Quantum
Entanglement.
entanglement basically says, yeah,
Yeah,
it says the horizon, right? And
it's the
what it also
horizon. Yeah,
says
quantum entanglement is the
is the reason
horizon.
the sky is blue. The reason the sky is blue
Exactly. Exactly. Yeah.
because
Hmm.
the ocean, right,
The
in the
mo
atmosphere.
an emotion and the atmosphere.
Of the
Exactly.
ocean,
The ocean. Oh, the ocean
the
and the
ocean and the
atmosphere.
atmosphere.
Exactly. Exactly. What about? Okay.
Light reflect.
All right. All right. What do you think about quantum entanglement?
You're funny. You're funny.
You're funny. Go on.
Okay, I'm
Oh
gonna
my,
tell you. So
oh my
quantum
God.
entanglement basically
You
means so
you're I'll tell
it's
you the
not true.
truth. You're making more sense than most physicists. So that's good.
No, 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 no. It's just thank you. But no, quantum entanglement is not real because gravity isn't even real in the first place.
Oh, oh, oh. So there's not even gravity. That's like that's new age stuff. All right. What do you mean by that? What do you mean there's
Well, at
no
least
hmm At
well
least you
because
hmm
it's actually not gravity. It's actually something called electrostatics. If you did
Oh,
not know.
electrostatics. All right. That's good. But what do you think about quantum
Yeah.
entanglement?
So I think that since if we're using gravity, then the Earth would have to be flat because gravity isn't real.
Okay. So, all right. I don't know what to tell you. Like, you actually make a lot of sense.
So are you gonna become a flat earther?
Of course, I am a flat earther. I'm, but I'm beyond. Like, I also believe that the sun is flat. Do you believe the sun is flat?
Dude, that's absurd.
That's absurd. I believe everything is flat. There's no three
The only
dimensions.
thing,
The universe is flat. It's only two dimensional. You didn't know that?
no, the only thing, brother,
Yeah.
is the Earth.
The only thing is the Earth. The only thing is the Earth.
No, the only
The only thing that's what? The only thing that's not a
I don't
toilet
believe in
paper?
I don't believe in planets.
You don't believe in planets? All right. All right. You don't
I
believe
believe in
that.
stars.
No, you don't believe in the stars. You don't believe in the sun. I don't believe in the
I do.
sun. Do you believe in the sun? I
Oh,
don't
I
believe in the
do.
sun.
Yes, I believe in the sun,
Wait, you
brother.
believe there's air? I don't believe there's air. Wait, you
Of
believe
course, I
there's
believe it.
wait, you believe there's an earth? I don't believe there's an earth. It's like there
I'll
isn't
tell you
even
something.
I don't even believe in a flat earth because there isn't even an earth. I don't even believe in
Hey,
flatness. I believe in single dimension. Everything is just a line. I believe in line earth.
that's impossible.
I
Actually,
no, hold on,
sorry.
hold on. I believe in zero dimension universe. The universe is dimensionless. How about that? I win. I win everything. No, no, no. I believe in negative dimensions. How about that? I believe in infinite negative dimensions.
Are you really gonna do this right now? You're really gonna do this, really?
Why not? I mean, you're saying everything nonsensical. What do you mean? Am I going? I win. You want to debate me in nonsense? I can easily win. I have superpowers
You're
when it
really
comes.
gonna do this. You're really gonna do this, really?
Yeah,
Are you
really.
sure?
Yeah, definitely.
So when is the time gonna end? When is the time gonna begin? And when is the time
Wait,
gonna
there's
start?
people joining. There's many people joining our stream, and you keep touching your mic. Wait, who's making
Because
noise?
they're all my fans. These are
Oh my God,
ban him, ban him. He's a hacker. He's gonna hack your account. I promise
he's
you.
gonna hack my account.
What's wrong? You don't like my music, Annie?
I love your music. You're very good a musician. You're very good a musician.
I love your music. Don't hack me, okay?
Repeat after me. Nam pat bor zumang. Say that.
I can't.
Okay.
Some very
There we
nice. Do you
go.
want to talk about quantum entanglements?
Why would I?
Of course I do.
I'd rather talk philosophy. Tell me, the majority of ideology doesn't mean anything. The only thing that means
God is
anything
real.
is whatever.
God has to be real.
No, let me explain. There are
God-
5 stages to human psychology. Wait, listen to me. Listen to me.
What does psychology mean? What does that mean?
Human psychology. The psychology of the way that
What does that
people
mean?
are in general. Common denominator.
Yeah, I know a lot about that without even I know a lot about that without even studying it. I'm just born understanding. I understand. Do you think everything we do is for our own benefit?
May I continue?
Oh my God. Yeah, you may continue. You may continuation.
Okay, so I'm not important. Okay, go ahead.
Number
No,
one.
we're all important, but anyone who wants to speak must to sing their speech.
I agree with you. I mean, I agree with you.
May I please?
Yes,
talk?
go ahead. Demystify.
Go ahead, brother. I'm allowing you. This is the one time I will allow you.
Okay, number one. Most people are angry, insecure, and they seek attention. Do you agree with this?
Wait, demystify. You gotta speak louder and slower and clearer and singer.
Blacker.
Why are you doing this?
Why are you whispering? You're like Joe Biden. Are you Joe Biden?
I don't know what to answer you with, man.
Why are you
Hear me out.
whispering? But why are you whispering?
Number one, most ideologies are a sneaky way to get resources. Do you disagree?
I don't know what you just said. I don't know.
All right.
But yeah. You mean, I wouldn't say ideologies. I would say religions. He left.
Did he leave?
Yes.
Yeah, I
Because
have a question for you.
Yeah, but I have to go soon because I need to go eat. I didn't eat yet today's.
What type of food do you eat? Do you eat food or no?
No, I just eat poop. I go down the street and I look for poop on the street and I eat it.
Hey, yo, no way, you capping? No, you for real?
Am I for real? Of course. The poop is the most delicious.
Yo,
I love
yo.
I love poop. I just go down the street and I usually I see people, I ask them to poop into my hand, and I just gulp it down. I love it. But you don't love poop?
Yo, nah, ain't no way, ain't no way,
No,
ain't no
I
way.
trust me, poop is the best. I love poop so
Add me, bro.
much. And sometimes
Add
I
me, bro.
take
I got
poop
somebody.
and pee and I mix them and make a milkshake out of it and I sip it with a straw. It's so delicious and nutritious.
What? Yo, nah.
Yeah, I'm telling you right
Yo,
now.
yeah.
Believe me. And
Yo,
it's
add me.
it's
Add me,
the
bro. Add me. Add me. Add me. I'd be, bro. I never met a poop man before, bro.
That's me. That's me. I think we're friends. Oh, except okay. That's me.
Yo, that's crazy, bro.
Wait, did you know this song? I'm a scat man. That's what he's talking about. That is what a scat man
I
is.
have a question. What does poop sound like?
Poop. It sounds like
I mean, what does it taste
tastes like chocolate.
like? Really?
Of course, it is chocolate. Chocolate is made out of poop. You didn't know that? When you eat chocolate, that's actually
No, it's
poop.
not. No, it's not. You capping. You for real?
Trust me, trust me. You gotta trust me
That
on
one
this
really?
one. Definitely.
That's why I like this. That's why I like this. Nah, you capping, bro. You capping. I thought it was made out of the food you eat.
No, it's chocolate is poop. Trust me. You gotta trust me. You're not trusting enough. All right, listen. I gotta
Okay,
eat.
okay.
I'm
gonna
starving. I'll see you later, man. I gotta
You gotta
go.
eat
I
some
gotta go
poop?
eat poop. Yeah, I gotta go down the street and ask people to poop in my. Sometimes I see people. I tell them to just poop straight into my mouth. Just poop straight in. Just. It's really the best. Poop is the best. There's no question about that.
Isn't your name
Pino. Yeah. Question.
black? Why is your name really black?
Why is my what black? What?
Your stream.
My
Your
stream
stream.
my stream is black?
In
What? Pino, what are you saying?
here?
Pino. Anyway, I'm gonna go now. I gotta go eat poop. I'm hungry for poop.
Wait, really?
Yeah, yeah.
Daddy,
I'm a poop eater.
Daddy, I'm coming. Oh!
Oh my god, he's
Oh my God!
did you goon?
Oh!
Did you
Oh! 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 my God!
Oh my god. Yeah, yeah.
Oh! Oh! Oh!
Very nice, very nice. Congratulations for pooping. Anyway. Oh my god. Bye. Very nice. How long have we been doing this? Also 2 hours. Okay, everyone. I think our job here is done for now. I'm starving. I'm gonna go eat. See you later.